Hi guys, and welcome back to the channel. I'm David. You join me today on Cherrybrook, my branch line station layout here at my new house. If you've not seen the previous update, I uploaded a week or two ago. I've moved in with my girlfriend, got a new house. It's through work, not sure how long I'm going to have the house, but for now I've brought Cherrybrook Station with me and I've been working on it at home in the evenings, on the weekends, and when I've had time off from work. Just wanted to start by showing you some major progress that's been going on the layout. I've started putting in, got an order from MBR trees, so they're dotted in all over the layout. Not installed yet, just sort of plonked in place. And something major I've been working on, if you've seen my Instagram, is the watermill section there. Don't worry, there will be a full video coming on all of this in the not so distant future. I think my next video will be about the electronics for the layout, just playing a bit of catch up there. Then there'll be a video probably on the watermill actually itself. And then at some point, there'll be a full scenery video coming out as well. Today's video, however, is about my plan for the electronics. Now, I'm filming this on the 25th of April 2025. That's this introduction section, and actually a section at the end of the video will be filmed today. However, most of the footage came from around February time, when I was actually planning out the electronics for the layout. So this video details the electronics I'm going to use, the point motors, the control methods, the control board that's inside this nice lever frame here, as well as my signals. I've got some Dapol signals, you can just see one down there, and the one that I've shown you previously by the watermill at the start of this video. Now you'll see throughout I've used an awful lot of DCC Concepts products, absolutely no affiliation, sponsorship, payment, anything like that. As I mentioned throughout, there are their sort of pros and cons. However, I thought I'd make use of them on the branch line as they are an incredibly popular brand, and I might as well make some sort of relatable content, and I had a load of point motors spare. Towards the end of the video, I'll show you exactly how I made this control box and mimic panel at the top there, and I hope that is of interest to some of you. But for now, let's go back in time and look at my control plan. Regular viewers of my channel will be aware that on the main layout, particularly in the storage yard, I make use of 9-gram servos and Merg servo control boards to control the points in the form of servo point motors. Now this was an incredibly cheap and efficient way of motorising the storage yard, and I will continue to use it on the rest of the layout. As it works really well. They're really easy to fine tune. I can get different speeds, I can get different end positions, and they just work really well. Now I could have continued this onto the branch line, but I wanted to make use of some things that I've had lying around for a while. So even longer term viewers of the layout will be aware that when I was at university, after the lockdown, I started making a portable branch line station called Cherrybrook. Now this is what this layout, or this section of the layout, is kind of inspired by. But one of the things I did buy for that layout were 7 of these. These are Cobalt digital IP point motors. And they're effectively a similar sort of motor to the tortoise point motor. It's known as a stall point motor. It has a DC motor inside and a gearbox, and when you apply a current, it moves from one side to the other. Now, something special about the Cobalt digitals, as the name implies, is they have a digital decoder built in. So there's only 2 wires going to this point motor. As you can see, we've got the black and the white, and they're going back to a digital controller. Now, I've had 7 of them sat in a box for a while. I've been tempted to sell them many times, but I thought, do you know what? Why not make use of them on the branch line? Now, obviously, using those 2 DCC wires, you can connect to any command station, meaning you can use your controller, or if you've got computer control, you can use the computer screen, or if you've got a phone app, you can use the phone app, etc., etc., and that will allow you to move the point like so. But if you don't want to operate using a controller or a screen, you kind of need to implement some sort of control panel. Now this is easily done using the DCC Concepts system, as it does actually have some connections down here for a switch. Now on the bottom of the motor here, you've got this green and orange contraption, and this is a form of terminal strip. So if you push down on the orange lever and feed your wire into the green bit, you get a relatively secure connection there. Now I say relatively as DCC Concepts use this on all of their products, and it is a reliable form of connection. It's sprung, it's nice and solid, but it can be slightly annoying because it really restricts the gauge of wire you can fit into the connector. Sometimes I find myself soldering to the tabs on the back, just so I can get a slightly larger wire on there. I often think they might have just been better off with a normal terminal block. And also you get problems like this, where those wires are hanging out slightly and they've just shorted out. But anyway, so right, single push button on the connector marked push button. Now if I push that, you can hear and see the motor is moving and doing its thing. Now you could run a load of these push button wires back to a control panel, and several people have done, and it works perfectly fine. Or you could add another product from DCC Concepts called an alpha encoder. Now this circuit board here is a DCC Concepts alpha encoder. It's already built into a control box that I'm partway through building. I'll be showing you this in more detail in just a moment. But if you imagine this wasn't in a box and it didn't have wires crisscrossing all over it, this unit here is the alpha encoder. Now this is one of the products from DCC Concepts that, whilst it is really, really good, great functionality, and it is one of the only available on the market. There are a few obscure versions from Lens and I think a few other brands, but it is extortionate. This is £80 brand new from DCC Concepts. I was fortunate enough to get this one for about £45 secondhand on eBay, which even that was a little bit steep, if I'm honest, for a relatively simple circuit board. I don't want to give DCC Concepts too much hate, but it does appear to be, that looks to me like a microcontroller there. A little bit of power management circuitry here next to the power socket. A nice 4-segment display. What was that? Yep, a second controller chip there. But yeah, unless this is all going to their research and development costs, perhaps, I think the £80 price tag is very steep. But as I said, I got mine for £45 on eBay secondhand. And what this does is take any switch, has to be a momentary action switch, and turns it into a digital command. So what I've done is I've linked up the same push button that was connected to the motor is now connected to the encoder, and I've got the motor here. As you can see, just the 2 wires going into it, the black and white. If I press this button, absolutely nothing happens. Now if I press the button, sends a signal to the encoder. You can see the 5 come up there, and as you saw, the point motor moved. Now, unfortunately, I can't move it back with this button, as it's just on the right-hand side of number 5. But if I had another button on the left, I'd be able to move the motor back and forth. And the great thing is, coming out of this, all you've got is effectively like a telephone or Ethernet cable, which goes back to your DCC command station. So again, imagine all of this wiring isn't here. I'll tell you what this is all for in just a moment. But it's literally just this board with a couple of switches, goes back through this cable to command station. Now, unfortunately, this only really works. It's designed to work with the NCE system, so it will work on whatever their system runs on. It also works on Lens ExpressNet, Digitrax. It will work on their system. I forget what they're all called. LocoNet, that's the one. And it will work on all those sorts of proprietary systems, some of which need a signal adapter. But unfortunately, as it doesn't output just a track signal, your single button press gets turned into a DCC signal, which only goes on their LocoNet connection or whatever it is over here. So what I've had to do is bite the bullet and spend another £20. This is getting even more expensive, just to make use of these 7-point motors I had left over, on an alpha sniffer. Okay, so this little silver box here is an alpha sniffer. Now this is an adapter to go from the encoder, which is in this nice box that, again, I'm going to show you in a second what I've been doing there, through this coiled cable. It comes into the sniffer, and then that spits out a DCC signal. Now, I think this is actually designed to go into what's called a sniffer port of an ECOS controller or similar, which has like a separate port for sniffing for commands. But it will work as a standalone accessory bus. So this, I believe, will go up to, I think it's 1.2 amps. From a 12-volt DC power supply, which you just plug in here, and it'll produce a 1 amp or 1.2 amp signal, which can go out to all your point motors and other accessories around the layout. So what I'm going to be doing for the branch line is I'll be running a track signal from my Merg controller, and that will run all of the track. And then alongside it, I'll be running another 2 wires in what's called an accessory bus. And this is just a separate DCC bus used to run accessories. Now, as I said before, you can connect any kind of switch to the encoder here, although it is preferable that it is a momentary switch. So what you're probably going to use, what is really common in the railway hobby, is one of these, which is a momentary push button. Now, these are dirt cheap if you buy them from an electronics supplier. You can get them in packs of 25 or 50 for probably about, I don't know, a fiver for 20 is probably a good price. And yeah, just small little push button switches, and if I was to wire that up to every one of these connections, it would work just fine. I could move my points back and forward as much as I wanted. Another type of switch you could try is these toggle switches. This is actually an on-on toggle switch, but you can get them so they're sprung in the middle, and this would spring either way and connect to that encoder, and once again that would work just as well. Something else you've got as well, this is a rotary switch. Now these are really satisfying. This is for a future project, which I'll show you at some point, I'm sure, and I'm pretty sure you can get these as passing contact or sprung, etc. Again, another type of switch you could choose. Now, there is another thing on the market available from DCC Concepts. Now, I'm sure all of you are aware that the real points on the railways were controlled by levers, which manually pulled what's called point rodding, a series of interlocking metal bars and chains and pulleys to move the points and signals on the railway. Now, there are various ways to model this, and I have been really looking into ways I could have a lever frame for the branch line. Now, there is an incredibly expensive option, which is to buy a brass metal kit, which comes with full mechanical interlocking, and you can add electronic switches to that, and I really nearly did do that. But I figured, as I had the DCC Concepts points lying around, I'd bought a DCC Concepts encoder to send the signal to those points. I might as well continue the DCC Concepts trend and use their switches. So this is a DCC Concepts Cobalt Lever S. Really long title. Basically all it is a couple of connections inside. So it has 3 switches. It has a momentary contact switch and 2 permanent contact on switches, for a total of 3 switches inside. And it has this nice mechanical action here at the top, so that springs up. If I could try and do it with one hand, there we go. And it clicks into place, and then if you pull the handle again, hard to do this with one hand. But there we go. You can see that it acts like a lever, and all it is an electronic switch. I ended up buying a load of them second-hand on eBay. Brand new, I think they're about £20 each or something. I bought a load of second-hand ones on eBay over a long period of time, and I've created this. So this is the lever frame for Cherrybrook. It's a total of 12 switches. Got these colour-coded levers down here and 3 at the end. So you've got the signals, what's called a facing point lock, which I'll talk about at some point, a point lever, another signal, point lock and point lever, and another signal. And these 3 at the end are just for the points in the yard. I've not bothered to colour code them, as they will act independent of the rest of the lever frame. As you can see, the next thing I want to talk about is signalling. Now, the rest of the layout has colour light signals, so I thought I'd take advantage of the branch line and be able to operate some semaphore signals. And this example here is a fine model from Dapol. Now, initially I was intending to go with some handmade signals, either brass kits or the ratio kits with some brass etchings added, and I still might do that in the future. But something that I've had on the wish list in my head for a while is a couple of these Dapol signals. Now, they come pre-motorised and lit, and if I just move one of them now, you can see they have a really nice action. And if I return it, these junction signals are actually servo-controlled and have a nice bounce action. In the future, I may replace these with some kits that have more detail. For example, the actual arm here really isn't too detailed, so I could even replace the arm on this Dapol signal with a brass version, but as a model on their own, they are very, very nice. Again, something else on the more expensive side. This video is going to be incredibly expensive if I was to add up all the cost, but once again I bought this second-hand on eBay, and I've actually got a home signal as well to go with it, just a single post and an arm, and that is already ready to go on the layout. Now, as I said, these come from Dapol with this nice box here on the bottom, which has the servos built in. It's pre-programmed with all the movements and things, and all you need to do is provide a switch which will move the signal arm. And that can be added in the form of a DC power supply, 9 to 12 volts on this black and red cable, and then 2 switches that come in the box that go on these coloured cables here, which are actually these toggle switches supplied in the box from Dapol. They're pre-connected to these yellow, orange and brown cables, and when you flick one of those, the signal will move up and down. Now, you might have noticed this switch isn't connected anymore, and what is a DCC decoder from Traintech. Now, this is the Traintech TTS C4, I think it's also known as just the SC4, and this is specifically made by Traintech to control the Dapol servo signals. They also make another version, which I have collected from eBay. All of this is second-hand to save on cost, which will control the older version. For example, the home signal I've got waiting on the layout. So now if I pull the lever on the DCC Concepts encoder board, you can see the signal goes down, return it, and it bounces to its on position. Okay, so we've covered point motors and point motor control. We've covered the signals and how they're going to be controlled. We've got one thing left that I want to show you. Now, this is a small accessory decoder from Uhlenbrock. I bought this actually originally for the original Cherrybook layout for a very similar reason. This is to control the lighting. So this is a really simple device. As you can see, I've got the same 2 black and white wires going into it there. That's the DCC accessory bus. And if I press a button on my control panel, you see the light comes on, and you might be able to hear a relay switching inside. Now, I think these are about £30 brand new. I got this one for £19 on eBay. There are a few floating around on eBay at the moment, and yeah, this is going to be used to turn the lights on and off. I'm just going to be using it to turn off all of the street and building lights on one switch, and then the overhead lights on another switch, but you could actually get creative and put one of these near every building or every couple of buildings and turn them off individually. Again, brand new 30 quid, a bit much, but 19 quid on eBay, really not bad to get 2 switches controlled from the push of a button anywhere on the layout that has access to your DCC bus. As of recording this segment, this is what the lever frame currently looks like. Let's go back in time and see how I made it.
Okay, I'm not too sure where I'm going to edit this into the video. This is actually before I've started filming anything. But I've got the lever frame here, and you can see I've been working on it over the last couple of days or week or two. I've started testing out all the wiring, been painting up the levers here. They do need some work, just sort of re-getting the brass back looking shiny, and I need to do something about the bottom of the levers not looking so great. But no, I want to make a box for this to go into. My idea was a small wooden box that could house the levers, then underneath it I need to fit the circuitry, so it's nice and neat out of the way, and then also I want to fit some other electronics in this, which I will show you later on. And I spent a while trying to design my own wooden box, but having thought to myself, I'm not a carpenter, I won't be able to make this look very good, what do I do? Do I do something else? I suddenly thought, carpenters do exist, and in fact woodworking factories do exist, so I just bought a box. I think it makes much more sense than making my own. So this is just a wooden craft box, or so-called wooden craft box from Amazon. If I can open it with one hand there, this is the perfect size to fit my levers in. Now, yeah, I got really fortunate. I spent ages searching on Amazon and managed to find this box. Basically, measure your lever frame, get a rough idea how big you need your box, and just search the internet. You'll probably find someone that makes it. This was about £10, I think, this box. It's really not too bad. Okay, so it's actually a few days after I filmed that first clip, and you can see I've got the levers mounted in the box. What I ended up doing was using actually a craft knife to cut a hole in the top. It's only thin plywood in the top of the box, and I've glued the levers in place. You can see what I've also done is just glued the alpha encoder to the underside of the levers here, and there's plenty of clearance if I close the box for that to fit in and sit nicely. A few of the other wires laying around. All the wires from the levers actually just come down from the lever and into the alpha encoder there. You can see we've got these spare wires left over. This is for something I'm going to show you shortly, where I want to use an Arduino to simulate some interlocking by having a red flashing light if I've done something wrong. It's a way of having the interlocking work without necessarily removing functionality, so I can still shunt stuff around quickly if I want to without having to fully signal the layout, or I can have this light flash up telling me that I've got a point set against a signal, etc, etc, but I'll talk about that again later on. The other stuff I've done then, I've got this RJ12 cable coming out of the alpha encoder here. It comes down along here and into a female to female connector, and that has a nice hole on the side of the box that it comes out of. And you can see here I've connected a blue LED. That comes up here. There's actually 12 volts on the end of the alpha encoder board, ready to go and supply another board next to it. So all I've done is just cut into that.
Okay, so mixed in with all the footage from back when I made this back in around, I think it was February time, there was various clips of bits and bobs. However, none of it was actually that useful. So here it is on the layout in April 2025. This is what it looks like, and I'll give you a bit of a tour and I'll show you how it works. And I think that'll be much more informative than showing you any more of the build process. Okay, so you join me front and centre of the Cherrybrook layout, and here is the control sort of centre. You can see I've got my Merg controller here on the right hand side, and this is the lever frame that I've been talking about. As you saw from the construction, it's literally just a cheap softwood box from Amazon. Cut a hole in the top, put the levers in, and then I mounted some electronics inside. It's mounted onto the front of the layout using a split pin hinge that I've actually modified very slightly. Half of it is on one side on the layout side and half of it down here. That allows me to sort of offset this to a lower height than the front of the layout. You can see also this full hinge here is holding the box closed, so if I pull a lever, the box lid isn't prone to moving. As you could hear there, the points are working. This wire, coil wire here, goes back into the alpha sniffer, as I showed you earlier on in this video, and that is used to control the railway. The levers themselves are wired into the alpha encoder. As you can see, if I pull this lever here, this point is moving. Back the other way. Move just there, and you can see that signal down there is on lever number 3. And that indeed goes down and returns home again. Something else I've added are these lights here down at the front. If I press a button, you can see it's possible to turn off the main layout lighting and turn on what will be the building lighting, but for now has only got those lamps there. I can turn the main lights back on, turn that off, any sort of combination. And that is using those Uhlenbrock decoders. There is, of course, some more electricity in this box, which I'll be showing you very shortly, because I do actually need to go in there and change a battery. However, first, I thought I'd show you the Mimic panel that I've made. So the Mimic panel sits on top of the layout and is made with a DCC Concepts Alpha Mimic, and I'll show you that very shortly. I did actually have some footage of me assembling this, and I realised it was kind of pointless, because it's basically a picture frame, and I printed something out. The diagram in the middle is made of a mix of my track planning software, simple computer-aided railway modeler, so that's how I got the track on here, as well as the signals and things and some of the buildings. I then took it into MS Paint, redrew it, put on the new font, used a bit of MS Word as well to put on some of these boxes and the font, actually completely redrew the track in Paint if I remember correctly. So it's all a lot of sort of manual work. There's no real easy way to make a nice looking diagram. But yeah, made up in a mixture of Paint, Word and SCARM, printed out on a normal printer and then stained with a tea bag to make it look old. I've used the same colour scheme as the old Western Region or GWR boxes. I also included, so we've got a green section here, a blue section, and that is in case I want to add block detection. I can have a green and a blue and a yellow block. There's a few nice details in here. So crossovers, greens equal main and red equals crossed. And then Fulford & Co. siding closed in 1961. So you can see this Fulford & Co. siding down here, I've actually marked as buffer installed 06 1964. And that corresponds to a dead end siding down on the railway. It allows me to have the industry there without actually having the full siding. And I'll show you that in a future video. Down in the corner here, we've got the lighting indication. So if I turn the main lights off and on again, you can see that light goes off and on. And if I turn the lamps off and on, they go on there. Top left corner is all my signals. So you can see it goes green as I've set a semaphore signal to the sort of off position. And then of course we've got the points going on down here. So the points down into the yard, as they move, the relevant indication changes. Added a switch in the corner which turns on and off the power supply, and that allows me to have the indication completely off or completely on. If I turn it around, you can see it is indeed just a picture frame. So all I did was get the bit of wood that's in the back of the picture frame, drill the holes, and super glue in all the little LEDs. I've then got the Cobalt Alpha Mimic installed there. There's some custom wires soldered on in some places, and that's for these LEDs, like so. And the way the switch is just wired in is in between this track connection here, so it disconnects and reconnects the track connection. That comes through to these blocks here, Wago blocks, and through to a nice XT60 plug. So this is a completely removable, completely free picture frame, and I can take it off the layout like so, pack it away nicely for transport. And then down here, I've got a nice plug that actually runs underneath the top of the frame. Okay, so as I said, there is some more electricity going on in this box, and that involves this little screen here, these LEDs, and this pair of switches back here. However, it doesn't currently turn on, and that's because it's powered by a 9-volt battery, which needs replacing. So this gives me the perfect opportunity to take this box off of the front of the layout and show you how it works inside. Okay, so you join me on my desk here. You can see it is literally just a wooden box with some levers in it. I've added a nice little plaque on the front, which I ordered online from a trophy sort of making company. And I need to remove these screws, the top screws from either side of the hinges. And that'll just allow me to open up the box and show you what's going in inside. Obviously you've already seen inside when I was assembling it, but there has been some stuff added. So right, let's get this opened and take a closer look. Okay, so I've got this opened up to replace this 9-volt battery here, and I'll show you what this is for just shortly. We'll get that done, see if anything comes to life. Now, a few of my friends and colleagues have told me how suspicious this contraption looks, but I can assure you it's entirely for the model railway. You can see we've got the nice alpha encoder unit in the centre there, and that's what I showed you earlier. There's a few more additions that have been made since I showed you this previously, obviously. In the top corner, we have the bottom of those push button switches. They correspond to these white wires here, coming down and into the alpha encoder. And that's just what converts this push button signal into the DCC signal to operate those Uhlenbrock relay decoders and turn the lights on and off. So that's nice and simple. The rest of this wiring and this mess up here is actually all for an Arduino Uno. Now, if you've not heard of Arduino, they're small microprocessors or microcomputers that are used just for simple logic operations. And if that makes no sense to you, please bear with me. Don't worry too much. But what it allows me to do is I've got these orange wires here coming up from each of these levers here, the first 9 levers, I believe that's 9, I'm not going to count them, yep, that's 9. The first 9 levers have an orange wire coming into the Arduino. The Arduino also has wires going to a small screen in here, a push button, a switch, and 2 red LEDs. I've also got just this up here is a 5 volts distribution with a lot of grounds here, 5 volts, coming from a power regulator board. And this little board here is actually what's known as a real-time clock. Right, I'll get that closed up. Very convoluted, very messy, but let's move on. Okay, so what that Arduino enables me to do, as I said, there's a wire coming from each of these switches. So the Arduino is aware of each position of each of these levers. Now, the real railways have something called interlocking, and that would mean, for example, I couldn't pull this signal at the same time as this signal. It wouldn't make any sense. And now I've not locked it, but what you'll notice is this little screen has flashed up with signalling conflict 1 and 2, and these red lights are flashing. If I remove one of those levers, that error message goes away. And the way I've achieved that is just by having a logic sort of program that I've written myself in the Arduino that knows the position of all these levers, and it knows anywhere that there shouldn't be 2 levers at once. So again, I can't have lever number 1 and lever number 3. That's a signalling conflict. The other thing it allows me to do is have a warning if I've pulled a signal and the point's actually not set that way. So for example, this would be setting the route into the goods yard, and you can see we don't have the route set. If I then pull the point lever for that route, the error message clears. Now, this isn't really a how-to guide of how I made this. I thought I'd just sort of show you what I've done. There's a few other modes for that screen, hence the push button. So if I press the push button, you can see we've got the time. That's what that clock module was for. And that is the real time, and that will be interrupted if there's any errors, like so. Or I can press this, and I've got the time still, but it's inverted my black and white. Just a few fancy things to try and make it look pretty. There is all sorts I could do with this technology. Arduino is really a simple concept. It's a computer that has inputs and outputs, and you can write all sorts of logic into it. You can also buy all sorts of sensors, screens, switches, buttons, LEDs. You can connect anything to it, and really the world is your oyster, and this is what I've chosen to make. I can't remember all of the conflicts that I coded onto here. It took a very long time for me to work out all of the logic for the different conflicts, but now I know I'm in safe hands for, there we go, route not set, pulled my points, and now it's going to stop shouting at me. I almost thought about putting a sort of speaker in here, but I thought that'd be really annoying. I thought a flashing light was enough and a description, and this final switch here just turns it off. So now I can control my trains without any fear of being shouted at by a little computer. So that was a really brief overview of how this signal box lever frame thing works. You'll have noticed I've got this 3D printed section on the front here. Needs some reinforcement, it's a little bit fragile, and that's just got the screen mounted in the centre there. That's an OLED screen wired back into the Arduino for anyone that's interested. I've also got this sort of section here with my lever frame sort of labels and numbers. This is temporary, although I seem to remember I accidentally spilled a bit of super glue on it, so that's almost definitely stuck in place now. However, I should be able to slide out the piece of paper that I've got those scribbled on and print out some nice labels in a nice font, and there is a bit of sort of acrylic on top of there as well to make it nice and shiny and reflective, so I will be reprinting those as well. But yeah, a little extreme for a lot of people, but for me it was something fun to do. It was a fun coding project to get the levers to come up with these warnings and flashing lights and things, and yeah, just add something fun to the operation of the layout. Okay, thank you very, very much for watching. As I said, the next video is going to be about the wiring of the layout. I've got a whole video on putting in the bus wires, the dropper wires, the point motors, the accessory bus, everything like that is all in one video, hopefully, depending how I edit it together, of course. And again, I think the next video after that will be on that custom scratch build of a watermill and bakery, and then some more generic scenery videos on the making of this sort of hillside. Tunnel portal there, a lot more work to go on that. I might throw in some footage as well that I've got of making the high street out of Batman Scenecraft buildings. If you want some more up-to-date updates, if that phrase makes sense, if you want more up-to-date progress, go ahead and follow my Instagram at Horsey Railway Modeler. That's probably my most up-to-date sort of channel of content. Also, for those that aren't aware, completely, entirely optional, I've made a Patreon and YouTube channel memberships. Please give me any feedback on pricing or anything like that. I'm thinking of uploading my videos on there early. I probably won't do it for this one, as there's literally no one subscribed to those. But I'm thinking of adding some perks like that, and just a way of making a little money back from this hobby of mine, so it's not so extortionate. Right, I've been shouting over this Class 33 for a while. Let's get that signal cleared on my lever frame and get it off to the station.